Huh?
You say put in what?
To Google, type in LBJ space versus VS, and then type in Shaq, and then type in zscore, and it should come up. And it should be third or fourth one down. See, I just pulled up another one, and it's a little bit, I don't know if the numbers are the same, probably the same. LBJ versus Shaq. Is that the same numbers? Should be the same. And it reads, with a height of 75 inches, Lyndon Baines Johnson was the tallest president in the past century. With a height of 85 inches, Shaquille O'Neal is the tallest basketball player on the Miami Heat basketball team. Who is relatively taller? Lyndon Johnson among the presidents in the past century, or Shaq among the players on the Miami Heat team? Presidents of the past century have heights with a mean of blah, 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 and basketball players have a mean of blah, blah, blah. Now, you ask this question, most of you redneck disorders are going to go, well, heck, Shaq is taller. Well, any idiot can tell you that Shaq is taller than LBJ. I mean, that's not what the question's asking. The question is saying who is relatively taller. Now, what does that mean, relatively taller? And what does relative mean? When somebody's your relative, that means they're what? Related. All right, so let's take out relative and put related in there. Who is related taller? What does that mean? Well, when you're related to somebody, that means they're in your what? They're in your family. So who is LBJ's family? Presidents. Who is Shaq's family? Basketball team. Now, what are the qualifications for being a basketball player? In other words, if you pull up the NBA and look up qualifications for basketball player, does it say that you have to be 6 foot tall? No, Spud Webb was 5'5", and he could dunk. Okay, so height is not a requirement, but it's a what? It's an advantage. The closer you are to the basket, the more shots you can get to go in the basket. So it's an advantage, but not a requirement. Let me ask you a question. If you have a son or a daughter, and they're in the 7th grade, and they're 6'2", what do you think the coaches are going to ask that student to try out for? Why? Because it's an advantage. So what can you say about basketball players in general? They're tall. So is Shaq a big fish in a little pond or a little fish in a big pond? He's a little fish in a big pond. Now, of course, Shaq is not little by no means, but what I'm saying is, in his population, he's normal. Okay, because there are some basketball players that are taller than Shaq. So he's normal because the population is relatively tall. What are the requirements for being president of the United States? We won't go there. Forget it. We won't go there. It has to be 42 years old, right? Or something like that. 36? We'll go with that one. We're not going to go with the other one. But what about being tall? No, because FDR was in a wheelchair. So he was only like 3 foot tall, 4 foot tall. Now, of course, he was taller than that before he had polio, but what I'm saying is we have no requirements for height. So you could have a 3 foot tall president, or you could have a 75-inch tall president, which is 6'3". All right, so is LBJ a big fish in a little pond or a little fish in a big pond? He's a big fish in a little pond because there are no height requirements. The only requirement that we have for President of the United States is 36 years old. Okay, so how are you going to compare these two individuals that are in two different families? You convert both of their heights to z-scores and compare them on the same scale. How you do that? Well, you use the z-score formula. And the z-score formula is x minus x bar over standard deviation. X minus x bar over standard deviation. And he stole the stylus again. Does he steal everything? Or somebody stole it. Let me go next door and get one because there's nobody in the room next door. Mouse.
You use one out of the phone?
I don't know if it'll work or not. Yeah, we could try it, but I don't know if it'll work. Let's see if it'll work. I don't think it will. No. I'm sorry. I'll just have to use the 2 rooms. There's supposed to be 2 on each board. So the definition is z-score is equal to x minus x bar over the standard deviation. Okay, or if you're dealing with a population, x minus mu over, I'm sorry, it's supposed to be standard deviation right here, and change this one to S. There. Same formula, just different variables, and that way you could, when you do this right here, you say, oh, that's population, and when you see this on a piece of paper or a report, you'll say, oh, that's a sample. So,
what did you say the other one was? Not
population, and this is x minus mu, MEW.
No, what is that other one for? The S100?
This is both of them, z-scores. Yeah, this is a z-score for the sample, and this is a z-score for the population. It's the same formula, just different variables. And the reason we make a big deal out of this is so, well, for instance, I'm taking a licensing exam Friday in Columbia, and I was studying something in a book, and it had sigma is equal to 2.5 degrees. So sigma means what? Standard deviation. So if, even if I wasn't a math person and I just took a statistics class, I would know that since they're using sigma is equal to 2.5 degrees, I know that is information not from the sample, but from the what? The population, which is a bigger group. And that's the only reason we show you the two different formulas, is so when you do get out in the real world, you are in a report or a presentation and you're given a folder, and in the folder there's a readout of all the information they're going over, and you see S or sigma, you know that is the standard deviation of either the population, the sample, or the population, and you won't have to raise your hand and say, what is sigma? Okay, you know. So, take your information that you're given, right, in the last two sentences, here, and here, and here, and here, and here, and here, and figure your z-score for Lyndon Johnson, and figure your z-score for Shaq, and then let's compare the two. Well, I write an email that says pens have been stolen again. And what room is this? Thank you. Built this. And what is your last name? Promethean. There are no capital styluses. I don't know how to. I'll just put an apostrophe at the end of stylus. I don't know if that's right or not. In AC 224 or 225. Did you get that? Did you get that? All are gone. Please help. There are no styluses. Did you get that? None.
Did you say that?
Yep. None. Dot, 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 zilch. Dot, 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 0. PS.
Ain't me.
There ain't there, and that's what I was going to put. PS. Where's the hyphen? You got to put 3 R's in that nairn. There ain't nairn. Of course, somebody's going to say, what is that word? There'll be somebody that say, what does that mean? Some dumb butt from up north that speaks perfect English. What does that mean? I do not understand. Shut up. All right. So let's take our handy dandy formula, and for LBJ, we're going to say 75. I love it when people go, well, how'd you know how to put 75? I don't know. I have no idea. I just guessed, you know, the formula standing right there staring at you. Okay? Yeah, oh, yeah! 75 minus, and let's see, what's X bar? X bar means average or mean, and in the sentence it says mean of 71.5, so maybe I put 71.5 there. I'm being facetious because I get people all the time, the first thing they say is, well, how'd you know where to put this, or how'd you know where to put this? How about reading the formula before you ask that question? Okay, now I've used that number, and I've used that number. What's the only other number tied to the presidents that I can use? And it goes on the bottom. Okay, now let's look at Shaq. 85 minus, let's see, what's the only other number? He's got an X bar too. 80 over, the only other number that's left is 3.3. The reason I get the question is because some people start to think, and they start to think, well, that's going to give me a negative number. I don't care. You don't change your formula because you're getting a negative number. And sometimes you're going to get a negative number. That means it's on the left side of the gas tank. All right? It's on the left side of half full. So just because you get a negative number does not mean that you're doing the problem wrong. And then what they'll do is they'll erase it, and they'll turn the numbers around to get a positive number, and they get it wrong. Don't start what? Thinking. Just do what I tell you. Plug and chug. All right. What's LBJ? What does his come out to be? 1.6. Okay. And what is Shaq? 1 point what? 5. So LBJ is relatively taller. The reason you know that is because his number is higher. The higher number is the answer. The higher number is your ER. Taller, bigger, faster. Okay? His number is 1.6. Now, what if we got -2 and -2.5? Which one would be your ER? -2. Why? What's better to have in the bank? $200, -$200, or -$250? I'd rather have -$200 than $250 negative. Okay? So your greater value is -2, not -2.5. All right, so that's how you compare apples to what? To oranges, is you put them on a z-score. And you need to write that down. When do you use a z-score? You use a z-score when you're comparing two different families. Basketball players to presidents, or apples to oranges, or students to teachers. Yeah. All right, so let's look and see what they got in the homework.
But on that test, it'll tell us like to use the
No, you got to read. You got to read the teacher's mind. No, it will say something relatively taller, relatively faster. It'll say use the word relatively in there. Mm-hmm. Yep. And you read the teacher's mind. Okay? So let's look at some problems and see if we can discourage y'all. No, I just do it I'm capturing, it's the last few weeks. I'm just capturing it on the screen. So you'll still get a video, It's just gonna be, I'm not gonna be on the,
Oh.
it'll be on the screen. Okay. For the one or two people that actually watch them. Study plan. Let's see. Let's look at one that I would put on the test. Eventually, if it'll load. 15 minutes later. There. I did pull up the right section. This is 12.1. Why are we in 12.1? That's not right. 12.5. Nope. Which section was it, people? Is it 12.5 or? Oh, it's 13, sorry. 13.3. 13.3. No. 13.6. 13.6. Now they're going to go another strand of the z-table. With the z-table, let me throw this in here for you. There's another branch of the z-table. You need to draw a picture. And I told y'all about this a long time ago. Normal distribution. Half a tank right there. That's 0. And we got the left side, which is -1, -2. That's your z-scores. And then we got your +1, +2. And your empirical rule says that 95% falls within 2 what? Standard deviations. Now that's why I wanted you to write down the empirical rule, because of that little bit of information. Now, there's also another way to look up probabilities, and it's called in the table, or area under a curve. So, probability can also be written as area, and it also can be written as percentages. So in this section, anytime you see those 3 words, you're talking about the same thing. Now there's 2 ways to find the probability or the area or the percent under a curve. One is table A2 in your book. Or you can use the TI-83, and I will show you how to do that. Okay? So if you have a TI-83, you might want to get it out, because it might help you out. All right, so first of all, if I asked you to tell me what the percentage is in this area right here, what would you tell me roughly what that area is? 50%, because it's half tank. All right. If I was to ask you what this percentage was right here, you would say 2.5%. Well, Hubert, how do you know it's 2.5%? Well, what did I just tell you? Between two standard deviations is what? 95%. Now, some of you out there, rocket science, what does that leave? 5%. That's not normal. So where is that 5%? Well, there's 2.5, and there's 2.5, and that equals what? 100%. So these two little tails right here are 2.5% each. So you need to write that down. Now, what if you get a z-score of negative 1.5? Well, then you have to look at the table. And the table, there's two tables. There's one, and there's the other. I'm just going to put these up here for a second so you can see them. There's two. I don't know if your book has them in the back of the book. I know most books have them in table A2. One side, what's the difference between the two? Negative and positive. What side of the bell curve represents negative z-scores? The left side. What side represents the positive z-scores? The right side. Okay, so we got that down pat. Also, you need to recognize table of area to the what? Left. Table of area to the left. What does that mean, Hubert? That means all of us read what? Left to right. All these areas that you see on this table are left to right. I meant left. What I mean. Well, let's go back to the handy dandy table. I meant the handy dandy curve. Here's your curve. And it's half full. Oops. Let me just do this. It'll be a whole lot easier. Half full, quarter full, almost empty, 3/4 full, almost full. Now there's your 0, 1, 2, 0, negative 1, and 2. Let's say that I give you a problem and I want you to find the area to the left of negative 1.5. And you draw a picture, because that's one thing that I tell you to do, is draw a picture, because you don't have to on these things. I tell students to take a piece of notebook paper, divide it up into 8 sections, draw a line in the middle and draw 3 lines, and then draw 8 of these, and then run like 15 copies. And if you do that, it'll save you a whole lot of time, but it takes about 15-20 seconds of work. So some of y'all may not be able to do that, but you'd rather draw this thing 30-40 times. I understand. Anyway, I want to find this area. Well, you know this area is 2.5, but you have no idea what this area is. So we know that this is negative 1 0.5. Now let me also tell you something else. When you see 2 decimal places in this section, I can't do this, so I'm going to have to use this. When you see 2 decimal places, example 1.23, comma, negative 2.25. When you see 2 decimal places, that is a z-score. Okay? When you see 4 decimal places, 0.0235, comma, 0.9935. When you see those guys, that means probability / area / percentage. So you take your handy dandy marker right here and you put a 0 right here, because that's what they're going to give you in the book. They're going to say a z-score of negative 1.50. Well, you know that's a z-score because it's 2 decimal places. So you go to your handy dandy table and you look up the negative z-score, because what? It's a negative z-score. And you look up negative 1.50. And I'm going to blow this up as much as I can. I think that's it. Yep, that's pretty much it. I don't think I can make it any bigger. I'll make it bigger this way. Yeah, that's about it. And you got to find negative 1.50. So, you know up here, and I tell students, just memorize the top. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 cents. 0 cents, 1 cent, 2 cent, 3 cent, 4 cent, 5 cent, 6 cent, 7, 8, 9 cent. So the first column is 0, because you don't want to have to look back up here. So 1.5. So I take my handy dandy highlighter. I'll take my straight line maker. And we'll make it blue, and we'll make it a little bit bigger. Negative 1.5. Well, that ain't going to work. Can't do it with the... Oh, forget it. Won't let me do it, but... Negative 1.50. There's negative 1.5. And then 0 is this first column. So where do they overlap? Where do the 2 overlap? Right here, 0.0668. And what is 4 decimal places? That's an area, or a percent, or a probability. So we go back to our handy dandy problem. And the area of the blue is 0.0668, or almost 7%. So, what does this mean in this section? This means that if you're given a z-score, what are you going to be asked to find? Find an area. Okay, now this is real tough. If you're given an area, what are you going to be asked to find? Find the z-score. Okay, I just did number 1 for you. Given a z-score, find an area. Now, you could write it as area of 0.0668, or you could say 6.68%, or 7%, or you could say a probability of 0.07. or 0.0668. That I'm not worried about. I'm worried about you putting 0.0668 on the test. That's what I'm worried about. Okay? So let's do our nerding. Let's go ahead and draw this laborious thing again. I wish there was a way we could use a copier and not have to do this over and over. Okay, I want to find this area right here. That's the area I want to find. And I'll give you the z-score in just a second. Make sure I cover everything up. So somebody say, what about that white area you didn't cover it up? Shut up. Okay. So, I take my handy dandy straight line maker and I draw it. There. And this comes out to be 1 or 0.73. So I've given you a z-score of 0.73. And those of you that have a book, do you have a table in your book? Probably in the back. Probably in the appendix. You'll probably say tables, and it'll be like the first couple of 3. Or it may be in chapter 13.6. Usually they make it a little cardboard table. Or it may be just on pages. I don't know. Let me see if it's in the book. Hold on. Let me see if there's a table. Index of applications. They don't have an appendix. No. They've got to give you a table somewhere in there because you got homework problems in the book. So it's got to be in there somewhere. Huh? Okay. 822 and 823?
Yes.
Okay, let me turn there. 822. Yep, there. They had to give it to you some way or another. All right, this one's on the right-hand side, so I'm going to go to the next page, and it should take me to the right-hand side. There it is. And I'll try to blow it up as much as I can. And we want 0.73. We want to know the area to the right of 1.73. Or 0.73, sorry. So we take our handy dandy highlighter and we look for 0.73. So 0.7 is right here. 0.70, 0.71, 0.72, 0.73. And we get, when we look up 0.73, we get 0.7673. And that's our answer, right? Yes or no?
Yes.
No, it's not. What did I tell you these tables give you? They give you the area to the what? What does it say right here? To the left of Z. We don't want the left of Z. We want what? The right of Z. So you can't get it in the table, so you quit. Yep, good. I got 2 yeps. That's a good thing. What do you do if you can't get, if your table don't say the right hand side, but you've got a table that says the left-hand side. Well, what is the right-hand side compared to the left-hand side? What is it? What's the C word I'm looking for? Huh? Complement. Did y'all say complement?
I say compliment. I'm just kidding. I say compliment.
This class really sucks. All right. Complement. Right-hand side is complement to the left-hand side. So, what are you going to do? What are you going to subtract point whatever, 7 blah blah blah. What are you going to subtract that from?
0.
1. Because what's under the curve? 1. Because your probability goes from 0 to what? 1.
Okay, I don't understand that at all.
What does our probability go to? From first week of class. I'm sorry. Okay, you don't know this, probably haven't gone to probability yet. Probability goes from 0 to 1. That's why you should teach statistics first. Okay? So if I tell you something has a 0.75 probability, then that means you got a 75% chance. Okay? You're not going to have a 1.25 chance. Why? Because there's only 100%. 1 is just like 100%.
It says 0 to 0.
There you go. So this could be written as 100%, and the 0 can be written as 0%. Now, not many statisticians like to use percentages, so they use the decimal. So the scale is from 0 to 1. So, with that being said, what's the area under this whole curve? 1.0000. 4 decimal places means area. So the area under this curve is 1.000. What is the area to the left of 0.73? Y'all just gave it to me. What is it?
1.4.
Give me the 4 decimal places. What? 0.7603? Okay, I'm going to ask you one more time. One person. Point what?
767.
Thank you. 7673. So 0.7673 is equal to the green. Now, if 0.7673 is equal to the green, then what is the yellow? It's 1.00 minus, well, $1 minus 76 cents is what? 24 cents?
Yep.
So it's going to be around 0.2400, probably a little bit less, be 0.2327. So your yellow area is 0.23. I know you can't see it, but I'm just writing it in yellow. 2327. Now to check it, you take those two numbers and add them together, and what should you get?
1.
1.
0.
1.0000.
100.
100. All right, so whenever you read a table, you're getting what side? The left of your z-score. That's the area. In order to get the right-hand side is equal to 1 minus the left-hand side. Write that down. I tell students in my probability class to remember this.
You see the right hand side is 1 minus the left.
Less than is equal to left-hand side. Greater than is equal to 1 minus the left-hand side. And that'll help you out tremendously. If your question says, what is the probability of being less than 1.25? You know that you're getting the left-hand side. So you just read your chart, you read your table, Get the left side, and boom, you're done. If it says greater than 1.5, you automatically know that once you get the left-hand side, you have to what? Subtract it from 1. And that'll give you the right-hand side. Greater than basically means right-hand side. And to get the right-hand side, it's 1 minus the left-hand side. All right, let's do the narrative. Do what? Let's quit. Is that what y'all want to do? Get the cardboard. You got to have 2 pieces of cardboard. You got to have 1 to live in, and then you got to have 1 to say we'll work for food. But you got to have 3 packs of cigarettes and a cell phone to hold that sign up, okay? Because they all have cigarettes to smoke while they're holding that sign up. And how much are cigarettes now? $5 a pack?
I think $5.76.
Yeah, they got cigarettes, but they need money for food. And they're talking on a cell phone. I think we should all just get out of our car and beat them up. What did she say?
And then they walk back to Walmart.
Yeah.
And they said that, like that page girl that's on it, she said that there was this older lady that was sitting on like an exit on 85, and when she was going to go shopping, she felt really bad when she was shopping because that old woman was sitting in a wheelchair and doing nothing. So she went back, like, to go back to give her money on her way home, went out of her way and everything. That woman got up and put the wheelchair in the truck and got off. That's why I'm giving her any money.
I would took pictures of her and sent it to the paper.
I mean, but I won't give anything.
And I don't give these people, I'm sorry. I'm a veteran. I'm a veteran of foreign wars. But I ain't giving people standing at a red light money and they have veterans written across it. Because I don't think we've hit rock bottom yet. The warranty on a car battery is 30 months. If the breakdown times of the battery are normally distributed with a mean of 48 months and a standard deviation of 8 months, determine the percent of batteries. Okay. First of all, you got to draw a picture. So draw you a picture before you even get started. It's mean and standard deviation. Gee, she's going to get that cardboard box. Get 2.
Did you know that every day this week is going to be the same day backwards? Like today is the 13th, it's 4/13.
Yeah.
15, or...
You got to write them out first.
Y'all know what I'm talking about. How are you going to do this again?
Quick, spell mom backwards. Spell race car backwards.
That was last year. I'm sorry.
All right.
Oh, man.
So first thing you want to do is draw a handy dandy picture.
I didn't know that was cool.
What?
That was last year.
What was last year?
That every day this week was going to be backwards.
Okay. Ooh, that's a little bit too wide. I think I might as well quit.
Yeah.
You know,
I was just
people that I like can go. I'll call your name out. Actually, this is one of my favorite classes. I really only have one. This is the favorite class. My 8 o'clock class, they don't say nothing. My 9 o'clock class talks too much. And long as Shelly's not here, this is my favorite. Oh, there she is.
I was on Facebook and I seen this whole thing that says, everybody's
She was on Facebook. Okay, well that's good. I'm glad you were on Facebook. Yeah.
like, I don't really understand this, so I'm not going to try. I'm going to let you walk me through it.
Okay. And while you're waiting, you're going to go on Facebook. Okay. All right, what's the mean? Y'all didn't write it down. Mean is 30 and the standard deviation is 8.
I didn't see it and I can't see that.
The mean is 48.
Okay, let me go back.
48.
Oh, I'm sorry. 48. There we go, thank you. So 48 and standard deviation is what, 8? So 48 goes in the middle. And 48 plus 8 is 56. And 56 plus 8 is 64. And 48 minus 8, I'll do that one for you. And I'll even do the next one for you. 40 minus 8 is 32. So let's say you buy a brand new battery. What is, if it goes out in 20 months, is that normal or unusual? It's unusual because it's down here. If it goes out in 50 months, is that normal? Yes. And if it goes out in 15 years, then that's very unusual. All right, so we've got our normal distribution, and they want to know, we'll take our handy dandy blue marker, and they want to know what is the probability of a do-jigger going out in 30 months. So there's 30. Did it say less than 30 months or greater? Let's turn back and see. It says the warranty on a car battery is 30 months. If the breakdown times of the batteries, blah, 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 blah. Determine the percent of batteries that can be expected to require repair or replacement under warranty. Okay, so that means under warranty, so that means less than 30 months, I would assume. Okay? So we need to have this area right here. So all y'all have to do is look up 30 in your table, right? Is anything that easy? No. 30 is not in your table. Your table only goes from negative 3.5 to 3.5. So we need to erase the 0 and make it a 3.
Yeah.
No, we need to change the 30 into a what?
Decimal.
A z-score. How did you get a class of losers? I don't know. I think they were handpicked. Z sub 30 is equal to 30 minus 48 over standard deviation is 8. Now somebody crank that out. I'm sorry, what? Negative 2.25. And somebody take your handy dandy table and look up $2.25. When I worked at Walmart back then, you had your OIL, and then you had your antifreeze and your radios. You had your accessories, and then you had spark plugs, because we sold spark plugs and spark plug wires back then. And this guy came in. I need spark plugs. I said, okay, what kind of car you need? I got a Buick 225. No, yeah. You got a Buick, yeah. He must have know the same guy. He said, I got a Buick 225. I said, okay, what size engine it got in? Deuce and a quarter. He thought the 225 was the size engine. And he'd say, deuce and a quarter. So, deuce and a quarter. Of course, a Buick, anything, a Buick back then was a tank. And it would have to have a 350 or better to pull a Buick. So, it had to have a 350 in it. The 225 is something that would be in a, who made the Comet? Ford? Yeah. Ford Comet or a Ford Fairlane? That would be a 225, which they don't even make a 225. I think it's what, a 247 or a 2... Huh? Straight six. Straight six. We're talking about spark plugs and she's talking about her hair. Looks good.
I think so too. So what, we're going to do a little 2.25?
Yeah, that's 15 minutes ago, yeah. Look up 2.25, everybody's done it. And what do you get? Huh? Well, she asked a very important question for those that are listening. All right. First of all, we need to go to the left-hand side. And look what these are increments of. How many decimal places? 1. You got to have 2. So, what's $2.25? $2.20 plus 5 cents. So $2.20 is right here. 0, 1, 2, 3, 4, 5. So it'd be 0.0122. So 0.0122 is your answer. 0.0122. So if you're a battery person, if you sell batteries, can you handle 1% of your sales coming back?
Yes.
Yes. Markup on batteries is pretty good. If you don't believe me, go out and look at the Meredith brothers. Dang old Preston and them. They got dang old nice house. Dang old Centerville Road. Dang old 2-story house. Dang old columns. All right. So let's do something else. Let's make this hard. We got to get this thing really, really challenging for y'all. What is it?
Nothing, just kidding.
Well, you got to be challenged, don't you? I mean, you don't want to be a redneck, do you? Redneck disorder. Oh, we do no math on no computer. Let's put... I want to know the area right there. And we'll say from there to here, and The red z-score is 1.6. And of course, this z-score is 0. And I want you to tell me the area right here. And then after this problem, I'll show you how to do it on the calculator. Let me ask you a question. If it's 30 miles from here to Greenville and 70 miles from here to Spartanburg, how long is it from Greenville to Spartanburg?
10. I'm just kidding.
40 miles. How'd you get that?
70 subtract 30 is 40.
So you took the big distance and you subtracted the small distance. So what are you going to do here? You're going to take the, I'll show you something, learned in the war. You're going to take the big area and you're going to subtract the what? The small area. And when you subtract the green area from the red area, what does that leave you? That leaves you with this area right here. So whenever you need to find between, and they will tell you between, you take the larger area minus the smaller area. So we got to look up 1.6. So we go to our handy dandy table and we look up 1.6. And 1.60 is 0.9452. Write that down. 0.9452. So our red area is 0.9452. And then we look up our green area. That's easy. Somebody tell me, I don't even have to look it up. What is the green area? 0.50, right? Half. But you can't say half, you got to give it a decimal, okay? And that's 0.500. So the green area is 0.5000. Now, what's 9452 minus 0.5000? 0.4452. So your mauve area is 0.4452. I just had my house repainted. Oh, I got to show you that. Okay. Well, while y'all working on the next problem, I'll show it to you. Alright, so the next problem, and we're going to do this one by calculator, but if you don't have a calculator, do it by the table. So we're going to take our handy dandy.
That's what I'm thinking.
Okay. I'll just draw this one in highlighter, that way it'll make it easier for y'all. I'm going to take this area. And the mauve area is going to be this area. That's the area I want. And then I'm going to take the red marker, and that'll represent the big area. And the red area is at 1.45. And the green area is 0.0, or I'm sorry, hold on, 0.42. Okay, so find that. Don't back up yet. We're not ready to go. That's rude. I got like 3 minutes. All right, Brown, Carey, Dawson, Charles, Edwards,
Here.
Elliott, Grubbs is here. Lee Croy. Lee Croy not here. Littman. Pardew's here. Queen is here. Not here. No. Satterfield. Shaw. Smith and Smith. No and no. Vernon.
Here.
Whitfield. Williford's here. Wright. All right, get your TI-83s out. Get your TI-83s if you got one. I'll pull it up. And if you got a TI-83, type second bars. Bars right there beside the clear button. VARS. And type normal PDF. And what was our left side? Point what? 0.4 what? 0.48, comma, 1 point what? And close parentheses. And there's your answer. 0.2347. I'll leave that on the board. And we'll do some more come Wednesday. Now, to show you my dang old paint job.